Welcome back for another deep dive. And today we're stepping into AI image generation,
Oh, cool.
specifically SDXL Turbo.
Okay. Yeah, I've seen some of the stuff it can do. It's pretty amazing.
Yeah, it turns text prompts into these really stunning images.
Yeah, and fast too.
Right.
Like way faster than some of those older models.
Yeah, that's one of the things that's really impressive about it. It doesn't take, hundreds of steps to generate an image.
Yeah.
You can whip one up in just a few.
Yeah, it's crazy. Like I'm still wrapping my head around how it can do that.
Right. It's like, how is it doing this?
Yeah.
It's kind of a mystery.
It is a bit of a black box, isn't it? Like we know it works, but the how is still a puzzle.
Yeah, exactly. It's like having this brilliant artist who never explains their process. You just see the amazing finished product.
Right, exactly. Like you see the masterpiece, but you have no idea how they got there.
Right. And luckily, though, some new research is using something called Sparse Autoencoders, or SAEs,
Yeah.
to help us understand what's happening under the hood.
SAEs, those are really cool.
Yeah. So can you break those down for us? Like, imagine you're explaining this to someone who's never even heard of an autoencoder.
Okay, so think of SAEs as like digital detectives.
Okay.
Their job is to go through all this data, all this information that's generated when the AI is creating an image. And they have to identify the key clues or features that the AI is using to build the image.
Okay.
And these features can be anything from really simple concepts like sloth or tuxedo to more complex ideas like party or even like artistic styles.
So they're kind of uncovering the AI's visual vocabulary.
Yeah, that's a great way to put it. It's like they're figuring out the basic building blocks of how the AI sees and understands the world.
That's so cool. So where does the Professor Sloth come in?
Ah, yes. The Professor Sloth. This is where it gets really fun.
Okay.
The researchers use this great example to show how all of this works.
Okay.
So picture this, a cinematic shot of a Professor Sloth wearing a tuxedo at a BBQ party.
Okay, I'm picturing it now. A very dapper sloth amidst the burgers and balloons.
Exactly. And the researchers wanted to see how the SAEs and these things called transformer blocks would handle this masterpiece.
Transformer blocks. What are those?
So transformer blocks are these special components within the AI. It's like they're different departments, each responsible for processing different aspects of the image.
Got it. So like one department might handle the composition while another focuses on the colors.
Exactly. And in this research, they focused on 4 specific transformer blocks that seem to have the biggest impact on the final image.
Okay, interesting. So did they find that each block had like a specific role to play in bringing this sloth vision to life?
They did. It was really fascinating. The first one they looked at was down 0.2.1, which they nicknamed the composition architect.
The composition architect. I like it. So is this block responsible for like the overall layout of the image?
Exactly. It's like the director setting the stage, deciding where the sloth should stand, where the tuxedo should go, all those BBQ party elements.
It's like the master planner.
Yeah. And here's where it gets really interesting. They could actually manipulate specific features within this block and see how the image changed.
Oh, wow. So they could like tweak certain aspects of the composition.
Yeah. Like, for example, there was one feature that seemed to be responsible for the background string lights you might see at a BBQ.
Okay.
When they deactivated that feature, the AI still generated a sloth in a tuxedo, but the party lights were gone from the background.
No way. Yeah. So they could literally turn the lights on and off in the image just by tweaking this one feature.
It's pretty amazing, right?
That's wild. What about the other blocks? What kind of artistic roles did they play?
Well, the second block they looked at was up 0.0.1. They called this one the Style Maestro.
The Style Maestro. Okay, so like some artists have a really distinct style.
Yeah. Like think Van Gogh with his swirling brushstrokes or Picasso with his abstract forms.
Yeah, totally. So is this block like dictating the overall style of the image?
That's a great way to put it. It's like the AI's personal art teacher.
I love it. Did they make any cool discoveries about this Style Maestro?
Oh, yeah. Some really interesting stuff. For example, they found that even when they gave the AI a completely empty prompt, meaning no text description at all,
Okay.
but they activated certain features within this up 0.0.1 block, and the AI still generated these incredible images.
Wait, no text at all. And it still made an image. What do they look like?
They were really cool, kind of abstract texture-like creations. It was like the AI was expressing pure style without any specific object or scene.
Yeah, it's so trippy. So it's like the AI has its own like innate artistic sense.
It really does. It's like it has this whole visual vocabulary and it's just waiting for the right cues to emerge.
That's amazing. Okay, so we've got the composition architect setting the stage and the Style Maestro setting the vibe. What about the third block?
The third one is up.0.0, and they called this one the detail specialist.
The detail specialist. Okay, I'm sensing a theme here with the nicknames.
Yeah, they're pretty great. So this block is all about adding those finer details that really make an image come to life.
Okay, so like the little things that make it feel more real.
Exactly, like wrinkles in clothing or the texture of a tree bark.
Got it. But was there a catch with this detail specialist?
There was. It seems like it needs context to do its job.
Context? What do you mean?
Well, like let's say there's a feature in this block that can add little party decorations to the scene.
Okay.
But if the other blocks haven't already established that the scene is supposed to be a party, this detail feature doesn't really do anything.
Oh, interesting.
Right.
So it needs those foundational cues from the other blocks to make sense of what details to add.
Yeah, exactly. It's like the detail specialist is saying, okay, I can make this amazing party hat, but first tell me there's actually a party happening.
That's a great way to put it. So it highlights how all these blocks are working together, right?
Yeah, it's this fascinating interplay between these different departments of the AI.
That makes so much sense. Okay, so to recap, we have the composition architect, the style maestro, and the detail specialist working in concert to create these amazing images. And the fourth block.
Ah, yes. The fourth block is midpoint zero, and this one's a bit more of a mystery. They called it the enigma.
Ooh, the enigma. That sounds intriguing.
It does, right? And it seems to be dealing with more abstract concepts like the relationships between different objects in the scene.
So maybe making sure the sloth is actually at the BBQ and not just floating in space?
Yeah, potentially. We still don't fully understand what this block is doing, but it seems pretty crucial for making sure the final image makes sense as a whole.
So we've got these three blocks with pretty defined roles, and then this mysterious fourth one that's adding a layer of complexity we don't quite grasp yet.
Exactly. And it makes you wonder what else is going on in there that we haven't discovered yet.
This is already blowing my mind. And I'm guessing they didn't just stop with one example, right? There's got to be more to this story.
Yeah, there's a lot more. They actually analyzed tons of different features across a whole bunch of different prompts. And their findings got even more interesting.
Okay, hold that thought. We're going to have to dive into those discoveries in part 2 of this deep dive.
Sounds good. I'm ready for more.
Me too. This is just the beginning of our journey into the amazing world of AI image generation. Stick with us, folks, because you won't want to miss what's coming next.
See you in part 2.
Okay, so last time we were talking about how researchers are using those digital detectives, those SAEs.
Right. The Sparse Autoencoders.
Yes, to figure out how SDXL Turbo creates images from text prompts.
Yeah, it's like peeking behind the curtain of the AI artist's studio.
Exactly. And we were talking about how those different transformer blocks within SDXL Turbo are kind of like specialized art departments.
Each contributing something unique to the final image.
Yeah, and one of the things that really blew my mind was that the blocks don't always stay in their lanes.
Oh, yeah, that's one of the most interesting things we found. Like, you think these blocks have their specific roles, right?
Right, like down 2.1 is the composition architect. So it's all about laying out the scene.
Exactly. But it turns out some of the features in down point 2.1 weren't actually controlling the composition at all.
Wait, really? What were they doing then?
Yeah. They were handling stylistic elements. Like, some of them could determine if the image ended up looking like an anime or a cartoon.
So the composition architect is moonlighting as a stylist. That's wild.
Yeah, it really blurs the lines. And it gets even weirder because some features in up 0.1, the style maestro, could actually add or remove elements from the scene.
Hold on, the style block is messing with the composition. That doesn't seem right.
I know, it's like the art teacher suddenly starts rearranging the furniture.
So what's the deal? Are these blocks just like playing musical chairs with their roles?
It seems like there's way more interplay between them than we initially thought. It's not as simple as one block for composition, one for style, and so on.
So how can the researchers be sure these weren't just flukes? AI is still a black box in a lot of ways, right?
Right, but that's where the quantitative analysis comes in. It's not just about those cool visualizations and nicknames. They wanted to make sure what they were seeing was actually statistically significant.
So they crunched the numbers to back up their intuitions.
Exactly. One of the things they measured was the specificity of each feature.
Specificity. Okay, remind me what that means in this context.
So imagine you have a feature for beach. If every image that activates this feature actually shows a beach, then it's highly specific.
Got it. But if it's also activating for pictures of swimming pools or lakes, then it's not as specific.
Exactly. And what they found was that the features were generally pretty specific across all 4 transformer blocks.
Okay, so those features were consistently triggering on similar visual elements across different images.
Meaning they're doing something meaningful, not just firing randomly.
So how did they test this specificity? Did they just look at a bunch of images and see what features were active?
They did that, but they also used a really clever method. They brought in another AI GPT-4o to try to caption the features they extracted from down 0.2.1, the composition architect.
So they had this other AI trying to describe what it saw in those features.
Yeah, it was like asking GPT-4o, hey, can you tell us what this visual information represents?
And what happened?
The crazy thing is it could. GPT-4o came up with captions that actually matched the visual elements in the images where those features were active.
Wow. So one AI is explaining the visual language of another AI.
I know, right? It's mind-blowing. And it's more evidence that these features are capturing real concepts, not just random noise.
That makes me wonder, are all these AI models, even the ones built differently, starting to see the world in similar ways?
That's a really interesting question. Maybe there are some fundamental principles of visual perception that emerge regardless of how the AI is trained.
That's a whole other deep dive we could do sometime. But for now, let's stick with this research. They talk about specificity. What else did they look at?
Well, another important thing was causality. It's one thing to know a feature is associated with a certain visual element.
Right. But it's another to prove that manipulating that feature actually causes the image to change in a predictable way.
Exactly. It's the classic correlation versus causation problem. So they wanted to figure out if these features were really calling the shots.
How do they do that?
They used a technique called activation modulation. It's like turning the volume up or down on specific visual elements.
Oh, cool. So they could amplify or suppress the activity of a feature.
Yeah, and then they'd see how the image changed.
Clever. What happened when they cranked up the volume on those features?
The results were often pretty dramatic, like amplifying a feature would make the corresponding element more prominent or more detailed.
And I'm guessing suppressing it made that element fade away.
Exactly. And the changes were specific to the feature being manipulated. Like amplifying a feature for clothing texture wouldn't suddenly add trees to the scene. It would just make the clothes look more textured.
Wow. So it's like they're controlling the image with these features, like puppeteers pulling strings.
That's a great analogy. And it makes you think, right? Like, what if we could eventually control AI image generation with incredible precision?
Yeah. Like if you want more trees, you just crank up the tree feature.
That's the dream. And this research is definitely a step in that direction, but we're not quite there yet. Not all features have this clear cause and effect relationship.
Right. And some of them, especially in that mysterious enigma block, have more subtle and less interpretable effects.
Yeah, the enigma is still a big puzzle. But maybe that's where the AI's real creativity comes in.
Maybe it's making choices that we can't fully predict or explain. It's like the AI has its own artistic intuition.
Possibly. And it's worth remembering that these experiments were mostly done with relatively simple prompts and visual concepts.
Right, so we don't know yet if these findings hold up with more complex scenes or ideas.
Exactly. There's still a lot to learn about how these features work and interact.
Okay, so we've covered specificity and causality. What other secrets did the researchers uncover about these visual building blocks?
Well, one interesting thing was related to sensitivity, which basically measures how well a feature responds to its relevant context.
Okay, so like a feature for cat should only activate when there's actually a cat in the image.
Exactly. If it's going off for squirrels or dogs, then it's not very sensitive.
Right, so how did they test this sensitivity? Did they just show the AI a bunch of pictures and see what happened?
They did that, but they also used those captions that GPT-4o generated for the down 0.2.1 features. Remember how those captions were surprisingly accurate?
Yeah, that was pretty amazing. But how did they use those captions to test sensitivity?
So they took each caption and used it to create a bunch of new prompts that were similar in meaning but used different words.
Okay, so like if the caption was cityscapes at night, they might generate prompts like a bustling metropolis after dark.
Exactly. They were checking if the feature still got triggered by variations on the same theme.
And did it?
For a lot of the features, yeah. The activation levels were still pretty high for those semantically similar prompts.
So those features weren't just reacting to specific words, they were recognizing broader concepts.
Right. It's like they're learning to understand the meaning behind the words, not just the words themselves.
That's really cool. But you said sensitivity wasn't perfect for all the features.
Right. There were some cases where a feature would be highly activated by the original caption, but less so by the similar prompts.
So maybe those features are more finely tuned to very specific visual details.
Possibly. But overall, the sensitivity results were encouraging. They suggest that a lot of these features are learning to recognize abstract concepts.
That's fascinating.
Right.
It's like we're starting to map out the visual language of AI. We've talked about composition style details. What about textures? How did the AI handle those?
That's a great question. And they actually made a really interesting discovery about textures, and the up 0.1 block the style maestro.
The style maestro, right. And I remember you were saying how activating certain features in this block with an empty prompt created those abstract textured images.
Yeah, it was like the AI was making art out of thin air.
So what's the new discovery?
Well, they took those texture-like images and analyzed them with a model called CLIP.
CLB, called what's...
It's a model that's trained to understand the relationship between images and text. So they used CLIP to measure how much those AI-generated images resembled the concept of texture.
So they were basically asking CLIP, hey, how textural are these images?
Exactly. And CLIP gave them high scores, indicating that the images were perceived as very textural. But here's the crazy part. The texture scores for some of those AI-generated images were actually higher than the scores for real-world textures.
Wait, the AI is making textures that are more textural than real textures?
Yeah.
How is that even possible?
It's mind-blowing, right? It seems like the AI has somehow distilled the essence of texture into an even purer form than what we find in nature.
That's incredible. It really makes you wonder what other secrets about visual perception are hiding inside these AI models.
It does. This whole research project has been a fascinating deep dive into AI image generation. We've seen how SAEs are helping us understand how the AI thinks visually, and we've learned about these amazing features that control everything from composition and style to details and even textures.
And we've gone from thinking of AI as a black box to actually getting a glimpse of what's happening inside.
It's like we're starting to decode the language of AI art.
Exactly. But this is about more than just making cool pictures, right? Yeah. There are some real-world implications here.
Oh, absolutely. Understanding how AI sees the world could have a huge impact on fields like medicine, self-driving cars, and so much more.
Okay, I definitely want to hear more about that. Tell me how this research could actually change the world as we know it. Okay, so you were saying how understanding how AI thinks visually could have a huge impact beyond just making cool pictures.
Oh, yeah, absolutely. Like, think about the field of medicine.
Okay.
What if we could train AI to analyze medical images, like x-rays or scans, and not just analyze them, but do it with incredible accuracy, even better than human radiologists?
Wow. That's a powerful idea. AI is like a medical superhero.
Right, using its supervision to catch things that doctors might miss.
I mean, that could revolutionize healthcare.
Yeah, it totally could. We could detect diseases way earlier, leading to more effective treatments and better outcomes for patients.
Yeah, that would be incredible. Earlier detection is key for so many diseases.
And it's not just about diagnosis. AI could also assist with surgical planning, help monitor patient recovery.
Oh, wow.
Even help design personalized prosthetics.
That seamlessly integrates with the body.
Yeah, it's like we're giving doctors and patients a whole new set of tools powered by AI.
It's amazing to think about all the possibilities. But you mentioned self-driving cars, too.
Right. Self-driving cars are another area where AI visual perception is crucial.
Yeah, because they need to be able to see and understand their surroundings, just like a human driver.
Exactly. They need to identify pedestrians, cyclists, other vehicles, road signs, all while dealing with changing weather conditions, unexpected obstacles, you name it.
It's a lot to process, more than I can handle sometimes when I'm driving.
Yeah, it's a complex task. So how can this research help make self-driving cars safer and more reliable?
Yeah, that's what I'm wondering.
Well, as we get a better understanding of how AI models learn to see, we can develop more sophisticated algorithms for their visual perception systems.
So the cars will be able to make better decisions based on what they're seeing.
Right. And that means safer, more efficient transportation that could revolutionize how we get around.
It's incredible to think that this research could have such a huge impact on so many different areas.
It really is. I mean, think about it. Robotics, manufacturing, security, entertainment, pretty much any industry that uses visual information could benefit from these breakthroughs.
Yeah, it's true. The possibilities are kind of endless.
They really are. Like, imagine robots that can do really complex tasks with human-like dexterity.
That would be amazing.
Or security systems that can identify threats with incredible accuracy.
So it's not just about making cool images. It's about using AI to solve real problems and make our lives better.
Exactly.
It feels like we're at the beginning of something really big here.
I agree. It's like we're on the verge of a new era where AI isn't just a tool, but a partner in discovery and innovation.
And as we keep learning more about AI's visual perception, who knows what amazing advancements we'll make?
Yeah, the future is full of exciting possibilities.
Well said. And for anyone listening who's as fascinated by this topic as we are, I encourage you to keep exploring the world of AI and all the incredible research that's happening.
Definitely. It's a rapidly evolving field with so much to discover.
And the next time you see one of those amazing AI-generated images, take a moment to appreciate the complexity and the wonder of the processes that created it.
It really is a testament to human ingenuity and the power of AI.
Absolutely. Well, thanks for joining us on this incredible deep dive into the world of AI visual perception. Until next time, keep those minds curious and those imaginations sparked.
See you next time.